Hi, welcome back. We're going to continue our discussion of the tree diagram, helping us to use the chain rule. Remember, the tree diagram is just a technique to help us organize our chain rule when we're taking partial derivatives with multivariables. For question number 2, we want to find the partial of w with respect to r. So this is where we typically tend to really like the chain rule, or the tree diagram. Notice w, my outside function, is in terms of x, y, and z. But x, y, and z this time are in different variables. S, t, and r, s, t, and r, and z is also a function of s, t, and r. And those are my inside functions right there. So when we do our chain rule, we have to keep in mind that we are substituting in all of these into our function w. So when we do our tree diagram, we start with w. Well, the first thing we're going to do is w is going to be taking the derivative with respect to x. So when I'm looking for my derivative, the partial of w with respect to r, the first thing I'm going to do is I'm going to take my partial of w with respect to x. Now that I'm at x, now I have to determine, well, x is a function of s, t, and r. But remember, we only want r, so s and t are our constants here. So now we're going to, from x we go to r, and that's going to give me my partial of x with respect to r. And we can keep going. Here's y. Y will also be taken with the derivative with respect to r. Z, also the derivative z with respect to r. And that can help us. This becomes the plus the partial of w with respect to y times the partial of y with respect to r. Man, I'm already making fewer mistakes. Plus the partial of w with respect to z, and then from at z, now I have to take the derivative with respect to r, the partial z with respect to r. And that would be our chain rule. Chain. So let's try this with some extra examples. Here we have w, which is a function of x and y, and x is a function of s and t, and y is a function of s and t. Our first example is we want to find the partial of w with respect to s. So when I look at w, well, the first thing I'm going to do is I take the derivative of w with respect to x. And then I take the derivative of x. Well, x is a function of s and t. I only want the s. Likewise, now I'm going to take that w, take the derivative with respect to y, and y is also a function of s and t, but I only want the derivative with respect to s. And let's see if we can do this in our head now. The partial of w with respect to s. So we take the derivative, the partial of w with respect to x, remember the partial of w with respect to x, and I can do that. I just get 2y times, and now I want the partial of x with respect to s, which becomes, well, the partial of x with respect to s is 2s. Right now, hopefully you guys notice, what makes this really shorter is we don't necessarily have to have the formula. We can just go straight to it as long as we follow those orders, the order in which we're taking those derivatives. So we don't have to write out this chain rule anymore. It makes it a little bit shorter for us. It's just a tool. If you want to use it, use it. If you don't, like this one, I don't like it, don't use it. Alright, so the next one, now we're going to take the partial of w with respect to y. Well, that just becomes dos equis. Stay nerdy, my friends. And now we're going to take the derivative of y with respect to s. Be careful. This is like saying s, 1 over t is a constant. This is like saying s over 5, and the derivative of that would become 1/5. So this just becomes 1 over t. And there's our derivative using the chain rule. Now the next one, we want to find the partial of w with respect to t. So let's try this one. W, take the derivative with respect to x, from here with respect to t. W with respect to y, and then y with respect to t. So if I follow, the partial of w with respect to t becomes the partial of w with respect to x, 2y, the partial of x with respect to t, 2t, plus, now the partial of w with respect to y, 2x, and then the partial of y with respect to t. Be very careful. This is s t to the negative 1. We should get negative s over t squared right there. And there's our derivative. Very easy to do this. All right, number 4. Let's take a look at number 4. We want to find the partial of w with respect to x, given w is a function of x, y, and z. So remember, we got x, y, and z here, so w is a function of x, y, and z. And that y is a function of s and t, z is a function of t, and x is a function of s and t as well. And we want to evaluate that when s is 1, t is pi. We'll talk about that evaluation later on here. So let's go ahead and set it. Let's take our derivative. So we want the w. We're going to go w with respect to x first. We're looking for the partial with respect to s. So we're looking at s. W with y, y with s. W with z, z with s. Weird looking s. There we go. So we can do this. Our partial of w with respect to s. First, partial of w with respect to x. And that's going to give us, equals y plus z. And then the derivative of x with respect to s. S is our constant. That just becomes times the cosine of t. Plus the derivative of w with respect to y. And that's going to give me x plus z times, and then we want the derivative of y with respect to s, and that just becomes sine of t, plus the derivative of w with respect to z, and that's going to give me y plus x. Here's the fun part. The derivative of z with respect to s, that's just 0, because it's a constant. T is a constant, right? So that's just 0 right there. So there's our partial right there. That's just 0. Next, we do want to evaluate this one. Evaluate. When s is 1, t is 2 pi. So we have to put everything in terms of s and t. Sort of. But we don't have to replace these. We just have to solve for them. When s is 1, t is 2 pi. We can solve for y. Y is just going to be s is 1 times the sine of 2 pi, which is 0. Let's do x. What's x going to be? Let's do the next first. X is going to be 1 times the cosine of 2 pi, which is 1. And then z, well, what's z going to be? Z is just going to be whatever t is. So z is just going to be what? 2 pi? And we can just plug all that in. So we can get our partial of w with respect to s at when t is 1. When s is 1 and t is 2 pi, we would get 1 plus z, or y plus z, so that would become what? 0 plus 2 pi times the cosine of t, which is just 1, plus x plus z, so 1 plus 2 pi, times sine of 2 pi, which is 0. So our final answer, just 2 pi, because that's just 0 right there. Alright, hope you enjoyed this video. Now, if you're feeling lucky, if you want to have some fun, we'll talk about this in class. Try this one right here. Okay? Try this one. Try to compute the second derivative in terms of theta for this problem right here. That'll be a little bit of fun for you. If you want to try that one, we will talk about this in class if we get to time. Okay? You guys have a great day, and I will see you guys later. Bye-bye.